Okay guys, today we're doing 4.7. It's the first derivative test, and yesterday you did the first derivative test with a graph. Today we're going to be doing it analytically, which means with algebra functions. Okay, let's get started. Okay, first thing, warm up here. This over here is an f prime. I've told you that before. I know it doesn't look like it, but all these are primes. Okay, f of x is increasing, then f prime is what? Well, if we know the original function is increasing, then we know the derivative, which means slope, would be greater than 0 or positive, however you want to think about it. Okay, if f of x is decreasing, then we know the derivative is the opposite of that. It's either less than 0 or negative. Okay, and then if f of x has a horizontal tangent line, remember we call those critical numbers. If f of x has a critical number, then the derivative is equal to 0. Okay, let's get started on some of these. Now here's what the first derivative test is going to do. The first derivative test is going to find all possible relative max and minimums. Okay, it does not necessarily find the absolute max or min, which you were doing yesterday on those graphs. You were finding absolute and critical maxes and mins. And we will just be finding today the critical, and here I use the words relative. That is the same as critical max or min, or you could also call them local max or min. The test is most likely going to be using critical if they even use this word at all. Okay, let's go forward. Now the steps to this are going to be the same steps as the previous two lessons, okay? The first thing is you're going to want to find your critical numbers, which means you're going to set the derivative equal to 0. Don't forget about your vertical tangent lines. So if you have a derivative and it has a numerator and denominator, you set both equal to 0. So here you're going to find the possible maxes and mins, okay? Now, you're going to set up your number line and check if they are maxes and mins, okay? And then a min means that it's decreasing from the left and increasing on the right. A max means that it's increasing on the left and decreasing on the right. So let's just, the same way that I wrote them out before, let's write down our rules. These are going to be the same rules, okay, but just written the same way I wrote them out in the prior two lessons. Okay, the first one means find critical numbers, which means derivative equal to 0. That's supposed to be a prime. Derivative equal to 0. Okay, that finds your critical numbers. Number 2, remember, set up your number line. On your number line, you're going to have your critical numbers, however many there are. Okay, these are all CNs for critical number. And remember, you're going to find test points before and in the middle of all of these. These are all TP for test point, not toilet paper. And then you're going to plug your test points into the derivative. And then let's just see what these do. Let's say you plug this test point into the derivative and it gives you a negative value. That means that the function is decreasing all the way up to this critical number right there. Let's say you plug in the next test point. So we'll call this test point 1. Let's say you plug in test point 2. The second test point, I'll call this one test point 2. And let's say it gives you a positive. That means it's increasing. Now, if you look at this, if the function is decreasing beforehand and then increasing, that means that this must be a minimum value. Okay, let's plug in like a third test point here. And remember, that's going to be increasing all the way until this point. Okay, so we're going to do the next derivative. We're going to plug in the next test point. Let's say we get a positive. So that means it continues to increase. Okay, this critical number would be neither a min or a max because it went from increasing to increasing again. Okay, let's say we plug in that last test point. Let's say we get a negative. So that means it's decreasing after that critical number. Okay, so this right here, if it went from increasing to decreasing, that would mean that would be a max at this critical number. And that's all we're going to be doing. We're going to be finding these points, the maxes and the mins of a function using algebra. And we're going to be using these 3 steps here. And that's the whole thing. So let's do a couple problems. Okay, so find the critical values. And you know what? Let's switch this up here. Instead of find the critical values, which is just setting the derivative equal to 0, let's find the max or min values of the functions below. Okay, so first thing is set the derivative equal to 0. So that means we need to find the derivative. So let's rewrite this. X squared minus 4 all raised to the 2 over 3. That's rewriting that. Now let's take the derivative. Okay, that exponent comes down, so we're going to have 2 all divided by 3. Our parentheses, we leave the stuff on the inside, right? X squared minus 4. Then our new exponent, we're going to do 2 minus 3, so it's going to be negative 1 over 3. Keep the denominator. And this is chain rule, so times the derivative of the inside, 2x. Okay, let's rewrite this. I'm going to move this whole thing to the bottom, and it'll now have a positive exponent. It'll be included on the bottom with that 3. So 3 cube root x squared minus 4. On top you have a 2 times 2x, which is 4x. Okay, this is the derivative. Now guys, I have included a graph of f of x right here on the side, and I'm just going to use this graph to show you that everything we're doing gets the correct answers. On the test, they would not give you this graph. Okay, so we found the derivative. The next thing is find the critical numbers, which means set the bottom and the top equal to 0. So 4x equals 0, and 3 cube root of x squared minus 4 equals 0. Okay, that gives us, if you divide by 4, you get x equals 0. And on this one, divide by 3, you get cube root of x squared minus 4 equals 0, because 0 divided by 3 is just 0. And then you can cube it. 0 cubed is just 0, so we have x squared minus 4 equals 0. And you add the 4 over, so you got x squared equals 4. And you square root, so you got x equals plus or minus 2. Don't forget the plus or minus when you square root. Okay, so now we figured out the critical numbers. Here's one critical number, and here's 2 more critical numbers. We need to set up our number line. Put all our critical numbers on it. So we have a negative 2, we have a 0, we have a 2. Okay, now remember we got to pick test points. So let's pick negative 3, negative 1, 1, and 3. Remember, we're plugging these test points into the derivative. Here is the final form of the derivative I had. I'm going to plug the test points into that. Now, I'm not actually going to rewrite all of them because that's going to take a long time if I do that. All I care about is if it's positive or negative. So let's write that I'm plugging all those test points into the derivatives over here. Okay, if I plug negative 3 into this, it's going to be 4 times negative 3. That's going to be a negative on top. So I'll put a divide sign here. Put a negative on top. If you put a negative 3 into the bottom here, it's going to make positive 9 minus 4 is positive. The cube root of a positive is a positive times 3 is a positive. So on the bottom we would get a positive. Negative divided by positive is a negative. That means that right here at this point it's decreasing all the way until we get to this critical number, negative 2. Look at this graph. Decreasing until we reach the critical number of negative 2. So that is correct. That's perfect. So far, our algebra matches up with our graph. Okay, let's check negative 1. On top, you'd get a 4 times a negative 1 would be a negative. On the bottom, you would get negative 1 squared would be 1. Minus 4 would be negative 3. The cube root of negative 3 is a negative number. I don't know what negative number, but it's a negative number. So, and then times a positive is negative. So it's still going to be a negative on the bottom. And a negative divided by a negative is a positive. So I know it is increasing at this test point, which means it's increasing all the way up till 0 at least. And then look at this. After negative 2, it is increasing up until our our critical number, which is 0. So our graph is matching up with our algebra still. Okay, let's plug in 1 and see if this works. 4 times 1 is a positive on top. A 1 on the bottom would give you negative in here, negative for the bottom. Positive divided by negative is a negative, so that means it is decreasing at this test point all the way up until 2. Look at this, decreasing until the critical number of 2. Perfect. Now let's plug in 3. Be positive on top. 3 squared is 9. I'm making this positive on the inside. And that'll leave us with positive. So that positive is positive, meaning it's increasing at that number. So we have where it's decreasing, increasing in each interval. Now it just wants to tell when it's a max or a min. Well, look at this number right here. It went from decreasing to increasing. That would have to be a minimum value if it went from decreasing to increasing. And look at this on our graph. Decreasing to increasing, this is a min. So we have a min at x equals -2. Okay, let's do it 0. It's increasing to decreasing. That would have to be a max at x equals 0. And look at the graph. Increasing, decreasing, that is a max, right? And then the last one here, at 2, it's decreasing to increasing, so that must mean it's a min at x equals 2. And that is a min, if you look at it. Okay, so there's how you do this. Now, if they do ask you not to just find the max and the min, but they ask you to find the max and the min points, which I do ask on the worksheet, and they do ask on the test sometime. Remember, a point means that it has an x and a y value. Okay, you're gonna have to denote it like this. So let's just do one of these. Let's say it asked me to find the max point. So let's say it was asking to find this, max point. Okay, well I found the x value. So the x value was 0. So my max is going to be 0, and I need to find the y value. Now, I wouldn't plug 0 into the derivative to find a y because that's going to tell me the slope. If I plug 0 into here, you should know it's going to give me 0 because that's how we figured out it was a critical number. So what I'm going to do is plug it into the y function. I'm going to plug it in right here. So let's do that real quick. Cube root of 0 squared minus 4, all being squared. Okay, that would give us 0 minus 4 is -4, squared is 16. We have the cube root of 16, which I don't know what that is. If I look at the graph here, that's going to be something like 2.5. Yeah, the cube root of 16. And I will just leave it like that though. Cube root of 16. And that is my x and my y value. That is a point. Okay, this is a point. This is where it occurred. And this is the value of that point. Yeah, that's the y value. Okay, and I just have one more slide here. This is an easier slide. Don't let it trick you. I'm asking you to find where it has a max and a min, and I am telling you this is the derivative. So that means you don't need to actually take the derivative. It's already given to you. So we're just going to find the critical numbers. We're going to set each equal to 0. But also don't get confused by my graph over here. This is a graph of the derivative, so it's not gonna be a graph of the original. So this graph is going to be kind of weird, and I'm going to explain that in just a second. So let's first find the critical numbers. I'm going to set each of these equal to 0. Okay, this one you could square root to get rid of that squared. So x plus 2 equals 0 because the square root of 0 is 0. So x equals -2 is a critical number. That's where the derivative is equal to 0. And x equals 1 is a critical number because that's where the derivative is equal to 0. Now remember I said this is a graph of the derivative. Notice that's where they are equal to 0. Okay, so they're graphing the derivative over here. They're telling me where the derivative is equal to 0. I just showed you that it was going to be at -2, which is right here, and 1, which is right here. Okay, so let's set up our number line because I got my critical numbers now. My number line will just have -2 and 1. Okay, some test points, -3, 0, and 2. I'm going to plug those into the derivative. -3, 0, and 1. Okay, and we're just looking at how, we're just plugging into here because this is the derivative. Just look at what it gives you. -3 times plus 2 is -1, squared is a positive, times -3 minus 1 is -4, so positive times a negative is a negative. So I know it's decreasing up until this point. Now, if you look at this graph, this function is not decreasing, but remember this is a graph of the derivative. And we said the derivative is going to be negative, which if you notice, it's below the x-axis, that means negative. Okay, so this is the negative side, this is the positive side. So this is correct. This graph is showing us the derivative is negative, which means the original function is decreasing. So if you wanted to, if they give you a graph like this, you could set up one of these number lines underneath it, create your critical numbers, which is going to be at -2 and 1, and then just put what signs they are. So this is a graph of the derivative, so I know since the derivative is negative, that means my function is decreasing here up until this point. Then, look at this, it's still negative, it's below the x-axis, so it's going to be decreasing again. Let's just show that that's true. Plug that 0 into the derivative, it's going to give us a positive. Plug a 0 into here, it gives you a negative. Positive times a negative is a negative, it means it's decreasing up until 1. Look, that's what I told you. Now, after 1, look, it's above the x-axis, that means it's positive, so that means that the function, the original function, is going to be increasing at that point. So let's see if that's true. Plug in 1 into here, that's going to be a positive. Yeah, 3 squared is positive. 1, I'm sorry, not 1. I'm plugging in my critical number. I need to be plugging in 2, my test point. And realize, notice how I noticed that that was a critical number because it would have given me 0 here. So I'm plugging in 2. So that's going to be positive times, in here it would be a positive, which gives me a positive times a positive. Positive means it is increasing right there. So if it's asking where is there a max or a min, well, decreasing to decreasing is neither. Yeah, that's not a max or a min. Decreasing to increasing, it goes like that, right? It goes like this. That means that this must be a min at x equals 1. Now, if you wanted to find the y value, I can't because I don't have a function to plug it into. But I know there's a y, a min value at x equals 1. And you could have looked at this graph over here and told the same thing because it went from decreasing to increasing. Now, if you would have been looking at this graph, it's a little confusing. But if anything switches from the bottom to the top, that means it's a min. If it switches from the top to the bottom, like let's say it went like that, that would have been a max. Okay, because this is a graph of the derivative, not a graph of the original. That's it.